We're here to talk about the MGL Avionics Odyssey EFIS. The Odyssey is the largest in a series of electronic flight information systems made by MGL Avionics. MGL Avionics have been around since 2001 and have shipped tens of thousands of instruments. The Odyssey features a large 10.4-inch sunlight-readable LCD display that has almost a 180-degree viewing angle. The heart of the EFIS system is the attitude heading reference system. MGL Avionics has spent considerable time and effort on our AHR sensors, and our SP4 and SP2 attitude and heading sensors are now in their 6th generation, and we're very happy with the performance. These AHR sensors are designed for both aircraft with a high wing loading and aircraft with a low wing loading, so the performance is very good in just about any aircraft on just about any platform, and the responses are very quick. Also, for those of you who fly aerobatics, we have an indication of the vertical when you pitch above 45 degrees, and same when you're pitching down below the 45-degree mark, you have an indication of the vertical. So some of you will find that very useful. And for those of you who like flying upside down, here's how the response looks when that happens. And back over. You home builders out there will really like this next device. This is what we call our RDAC. It sends all engine data through the serial cable to the back of the EFIS. All engine senders are connected to this device, and so this eliminates the need for a complicated wiring harness or from running too many cables through the firewall. So this really helps with the installation time. So let's have a look at some of the items on the screen here. This is set up as our page 1. We have up to 9 pages that the user can configure. Right in the middle here, of course, we have the attitude depiction, which takes up most of the screen. Here we can see the 3D synthetic terrain. We're in a pretty flat area right now, so the terrain is not showing up as much as it could. On the left-hand side here, we have the indicated airspeed tape showing 74 knots. And a little bit lower to the left here, we have the true airspeed at 80 knots. And our GPS simulator is showing a ground speed of 1 knot here. And just to the right, we have the real-time wind speed and direction vector, which is showing 79 knots. Wind from the right. So that's pretty useful. Right in the middle at the top we have magnetic heading with a magnetic heading tape and a magnetic heading bug, which is used with autopilots. You use the rotary controls to move the bug, and if you press the rotary control in and turn it, the bug moves in smaller increments. So that's the bug. On the right hand side we have the altitude tape showing about 400 feet, and just to the left of it we have the height above ground level showing 303 feet, and that's using the onboard GPS and the terrain database that's on board. At the top here we have the altimeter setting showing 3021. This can be adjusted using the barrel pressure up and down arrows or the rotary knobs. Here we have the VSI showing a descent of 800 feet per minute and showing a climb of 650 feet per minute. That's indicated in graphical format and with a digital readout. Over here we have the G-force indicator, and it's reassuring to see that we're at 1 G. I'll just play with the attitude sensor here, which contains the accelerometers, and there you saw 0.9 Gs. In the middle here we have the slip skid ball that also requires the SP4, and on the left here we have the angle of attack indicator. The pressure ports are included in the rear of the EFIS and will work with any differential pitot tube. Here we have the engine monitoring area. This can be set up for any engine. This one is a 4-cylinder Lycoming. All engines are supported, including twins. And on the left-hand side of the screen here, we have the information area. This can be changed by pressing the page plus or page minus buttons on the display. And we have several different pages available here, including this terrain look ahead, this auxiliary information page that includes information like density, altitude, and fuel endurance, and this little engine monitoring display. Any images can be imported into the display of the EFIS system. And let's have a look at some of the other pages we have set up. Pressing button number 2 changes the main page display to page 2. And as you can see, it's basically the same except we have a moving map display. This is the Los Angeles Basin. As you can see, besides airports, we have roads and rivers, cities and towns, airspace, and a terrain background. And if you want to zoom into and out of the map, the zoom buttons are over here. They can be zoomed a number of levels. The mapping that's shown here is a free database that is culled from the FAA that we give away for free. We also support Pocket FMS for those who prefer to pay, and we will be supporting Jefferson soon. So here are a number of zoom levels. And let's have a look at some of the other pages. By pushing the number 3 button, we have page 3. And as you can see, this is a split screen with an ADI display on the right-hand side. And on the left-hand side, we have a navigation display. If you have a Mode S transponder with TIS, Traffic Information Service, or Xeon's XRX traffic monitor, traffic would be displayed on the screen as well. And on the top right here, you can see the heading bug. If you turn the rotary knob, the heading bug moves. Let's have a look what we have on page 5. This is a full page moving map, and this is just one of the many options we have for a display. Pushing button number 4 shows that there's no page set up for button number 4 on this display unit. So let's have a look at the use of the rotary controls. The Odyssey can be used to control a compatible radio. If you press in the knob and turn it, it adjusts the kilohertz on the radio. If we want to select the function of the rotary knob, you double click it, and then there are a number of options you can choose for the rotary knob. Here we have baro selected, so we're adjusting the altimeter, and you can see the altimeter adjusting. So knobs can be pressed, they can be rotated, they can be held in and rotated, and they can be double clicked. So let's have a look at some of the second functions of the buttons on the keypad. Every button has a second function like go to, radio, and nav. To access any of the second functions, you first have to press the shift key, and that indicates that the shift key has been depressed, and then the button with the second function that you want. The go to button brings up the nearest airports. There you can see Torrance Airport is at the top, 0.2 miles away. That's where we are right now. If we press the down arrow, we can see some airports that are a little further away. Like here is Catalina Island, or KAVX. If we want to go to that airport, we just press the number 2, and now you can see we're going to Catalina Island. If we go to page 1 that has the attitude depiction, there you can see our highway and the sky boxes. Green boxes all the way to Catalina Island, just follow the boxes. Another very useful function is the airport information function. Pressing the 0 key at any time will bring up the closest airports. Here you can see a list of the nearest airports. There's a little arrow telling you the direction that each airport is relative to your position, and also the distance. So 0.2 miles for Torrance again. If we go down the list to Hawthorne here, 7.2 nautical miles away, Hawthorne Airport. If we want information on Hawthorne Airport, all we need to do is press the 4 button on the keypad, and that will bring up all the frequencies and runways for Hawthorne Airport. As you can see, all the frequencies are listed here. If you have a compatible radio, you can select any of these frequencies just by pressing the corresponding button numbered 1 to 9. So if we want ATIS, you would just press button number 1, and ATIS is automatically set to your radio. Let's have a look at another second function, the radio function. So let's press shift and then radio. This brings up a list of commonly used frequencies, and if we have a compatible radio, once again, we can send this frequency to the radio with a push of a button. So let's get emergency 1215, and the radio is set to 1215. Let's have a look at a few more functions. Let's check out the route function. Let's press shift and then route. This brings up the route menu. Here we can activate or restart a route forward or reverse. We can create a new route, and we can import a route, either from the system or the SD card. And we can press menu to back out of that menu. Pressing the menu key at any time will enter the main menu, or it will back out of the menu. Let's have a look at the main menu system now. Pressing the menu key will bring up the main menu level 1. This is a list of our commonly used menu items. It starts with the daytime or nighttime setting. We can end the current flight, we can cancel the go to, we can access our route manager, and our fuel totalizer functions are here as well, and stopwatches. Number 9 is our weight and balance calculator. We can press number 9 to access that. And here's our weight and balance calculator. This one is set up for an RV7. If we want to change the pilot weight, all we do is press button number 1 and enter our new pilot weight of 185 pounds. And here we can see our full fuel and empty fuel CGs are calculated. The weight of the fuel is automatically calculated based on the known fuel level from your senders and the known weight of the fuel, so no entries are required here. We hope that you'll consider MGL Avionics for your next EFIS.